Guys, welcome to another episode of CCNA tutorial 200-301. Today we're talking about what networking is and basics about networking. What is a computer network? So I've written here, I wrote a computer network is a set of computer sharing resources or data located on the computer or another network node. Before a computer can share data packets within between each other, there must be an agreed protocol, a set of rules that have been laid down before they can share data together. Most of these rules are also known as HTTP, FTP, and TCP. These are some few protocols that we are aware about, but these rules has to be laid down before a computer can share, um, before a network can share data together. What is a node? A node is a connection point amongst network devices. Sometimes the word node can confuse us most of the time. Just see node as your phone, your computer, your network, your router, or your switch. These are points, these are endpoints in which information gets to. So a network node is also known as your computer, your server, your switch, your router, as long as the information transfer passes through the Ethernet cable down to a particular device. That device that the information gets to is considered a node. Like I said earlier on, network protocols are a set of rules that needs to be established before a network can transfer data from one computer to another or from one network to another. These are set of rules that must be followed. A good example are HTTP. Under HTTP, we have HTTPS as well. We also have TCP, we have UDP, and we have FTP. In the next tutorial, I'm going to focus on HTTP, TCP, UDP, and FTP, what they stand for and what their job actually are. What is a switch? A switch is a networking device that connects devices in a network, allowing them to exchange packets. One important thing you should know about a switch is that a switch can only connect two devices alike together. So a switch can connect two computers together, and that's it. A switch cannot compare a computer to the internet. It can only connect a computer to another computer just within a local network, not over the internet. That's what a switch does. A router, unlike the switch, can connect a device to the internet or basically, yes, to the internet. Internet doesn't necessarily mean you have to go on Google or no. As long as the network you're trying to connect to isn't in where you are. Let's say you have two offices, one in Manchester, the other one in London. You need to connect your computer in Manchester to the computer in London. You need a router for that. So a router can connect you over to the internet, unlike the switch. A router can basically do the job of a switch and it also serves as a gateway to the internet. If you need to go to the internet or you need to connect your whole device or your whole office to the internet, a router is what you need, not a switch. In order to connect devices together, we must talk about the cables. What are network cables or what are the different type of network cables? We have straight through cable. A straight through cable can connect the computer to the router. A straight through cable can connect devices alike together. So a switch can connect, straight through cable can connect a computer to a computer. What is a straight through cable? A straight through cable is a cable that allows you connect different devices together. When I mean different devices, I mean both the computer, the router, the switch, the hub, the server. A straight through cable allows you to connect various devices together. And under straight through cable, we have different versions. We have Cat 5e, Cat 6e, Cat 7e, and the rest goes on and on. I will discuss about all those type of all the different. I will talk about these different type of cables in the next tutorial. Cat 5e, Cat 6e, Cat 7e. The difference is just the speed, nothing more. Some cables can transfer data between within 100 megabytes per second. Some can transfer data between 10 gig per second. These are the difference between the Cat 5 and Cat 6Es. Next tutorial, I'm going to talk about all those different type of cables next in the next video. Next, we have a crossover cable. A crossover cable can only connect devices alike together. A good example is a switch to a switch, a router to a router. You cannot use a crossover cable to connect a router to a switch. You can only connect, you can only use a straight crossover cable to connect a router to a router, a switch to a switch. The device must be the same. Next, we have fiber optics. Fiber optics is considered to be the fastest type of cable. It's also known as optical cable. Fiber optics uses light pulses to transfer data. It uses light pulses. If you're into CIA or FBI type of movies, and you hear them say, "Oh, we just received information from somewhere like North Korea," if you understand, data like that are transferred using fiber optic cable. The whole world is connected using fiber optic cable. These fiber optic cable are buried beneath the Red Sea, the deep part of the ocean. That is where these cables are located. And it's fast and it's more reliable, unlike the RJ45 or straight through cable as we call them. Now, speaking of RJ45 is sometimes considered registered jack. All Ethernet cable except fiber optic are supposed to use RJ45. RJ45, a good, I will show, let me just go on Google. This is what RJ45 looks like. This is what RJ45 looks like. This particular head, not the whole cable, not this wire, not the yellow wire, just the mount. This mount right here is the RJ45. The wire is what we call Cat 5, Cat 6, Cat 7E. But the head is RJ45, also known as registered jack. Now, let's go to Cisco Packet Tracer. Like we said earlier on, in cabling, we have I'm going to bring in two PCs. I'm also going to bring in two switch and also two routers. Now, in the tutorial, we said earlier on that a crossover cable can connect devices alike together, like for example, a switch to a switch using a crossover cable. Let's test that theory. Now, if you go down to your lightning bolt on the hair, and you click on, if you hover your mouse around this bit, you should see the names of the cables. This is a crossover cable and this is a straight through cable. So we are testing crossover cable to connect devices alike. So click on this to connect with this guy here. And here you have it, ladies and gentlemen, it works. If I press forward, this green arrow means it's connected successfully. Now, same thing for router, from one router to another router. Now, the reason why this isn't showing green is because the router isn't turned on. To turn on the router, click on your router. Let's zoom in. Yeah. Turn on the ports and go to the other one. Click on configure. Click on the Ethernet port you connected to, then turn on the port as well. And here you have it, it's connected. The crossover cable allows devices alike to connect to each other. But if I should use a crossover cable to connect from a switch to a router, it's not going to work. Even if I turn on the ports, oh, it worked. Okay, but it's not recommended at all. It's not recommended you use a crossover cable to connect two different type of devices together. It may work, but in real life, it's not. This is just simulation. But in using hands-on devices, you are not supposed to use a crossover cable to connect different devices together. It's a rule. Now, same thing for the PC. If I use a crossover cable, if I use a crossover cable to connect a PC to a PC, it should work because these are devices alike. Now, to connect different devices together, let me get rid of this. To get rid of this connection in Cisco Packet Reader, click on this arrow, this icon here. It says delete. Click on it and cancel all the connections. To connect various devices together, you need a straight through cable. What straight through cable does allow us to connect a PC to a router, a PC to a switch. These are not the same devices, these are different devices. So here you are in your home, this PC is in your house, and you need to connect to the internet. You need to connect to the internet. First of all, you have to connect to a switch. Your PC has to be connected to a switch. Then the switch has to be connected to a router that connects you to the internet. This router is considered a gateway. During the tutorial, I'm going to discuss about gateways and all of that. This router is considered a gateway to internet. Same thing here. Simple as simple. So this is how the network cable work. We have crossover cable, we have straight through cable, and we have fiber optics. Now, in order to configure your router, if you need to configure your router in real life situation, you need a cable called console cable. What console cable allows you to tap or access the terminal of a router or a switch. A good example I will show you. If you click on your crossover, your console cable, and you click on this RS232, click on it, then you connect to your router and click on console. Now, in simulation, you can access or you can configure the router using three different ways. First of all, if you click on configure, you can configure your router here. You can put in the IP address and the subnet mask and all of that. Or you can also configure your router using CLI, command line interface, using here, just like the way you use command prompt. Or you can come to your PC, click on desktop, and click on terminal. Just click on OK. The same thing as that of the router. The same thing. This is me. This interface here. This interface here is the exact same interface on the router. This is me trying to configure the router using my PC. It's not configuring the router using the router. This is me trying to configure the router using my computer here. That is what the console cable allows you to do. Console cable allows you to configure any devices at all from your PC. If I should connect this to the switch as well, it's the same thing. It's gonna be the same thing. I can now configure the switch from my PC. Okay. And that's what console cable does. So I'm going to stop here. In the next tutorial, I'm going to cover a more in-depth topic about protocols and how to calculate and configure IP addresses. See you in the next video.